This video is going to go over a couple of problems on our test review for Chapter 5. My first request was for number 3. So anytime that you have an exponent outside of the parentheses, the first thing that you need to do is apply that exponent to everything inside. So you're multiplying this exponent to all of the exponents inside the parentheses. Remember that the 3 actually has an exponent of 1, and so does that 2. So we would have 3 to the 1 times negative 2 is negative 2. X to the negative 2 raised to the negative 2. Negative 2 times negative 2 is 4. 2 to the first raised to the negative 2, that'd be 2 to the negative 2. And then x to the third, multiply the 3 and the negative 2 to get x to the negative 6th. Okay, negative exponents move, positive exponents stay. So right now I know that x to the 4th is going to stay put. 3 to the negative 2 is going to go to the bottom where it's 3 to the positive 2. 2 to the negative 2 will move to the top where it's 2 squared. And x to the negative 6 will move to the top where it's x to the positive 6th. Now 2 squared is 4. 3 squared is 9. And when we have x to the 4th times x to the 6th, that's when you add those exponents together. X to the 4th means 1, 2, 3, 4. X to the 6th means 1, 2, 3, 4, 5, 6. How many of them do we have all together? We have x to the 10th. So 4x to the 10th over 9 would be your correct answer. The next one that we should go over is number 5. The big thing that you need to remember with scientific notation is that positive exponents on that 10 are really, really big numbers. And negative exponents indicate tiny, tiny little decimal numbers. So 8.42 times 10 to the 5th, because that is a positive 5, we're talking a big number, like thousands. So we need to move the decimal point to the right 5 times. So 1, 2, 3, 4, 5. And it's kind of weird in there, so if you need to like write it out to the side, 1, 2, 3, 4, 5, fill in those blanks with zeros. So this is going to be 842,000. In B, this is a tiny, tiny decimal. So this is going to have times 10 to the negative. So when we move the decimal point, however many places we move the decimal point, our exponent on that 10 is going to be negative. So we want the decimal point to be after the 5. So 5.73 times 10 to the negative. And then we have to look at how many times would we move the decimal point to get it there. So 1, 2, 3, 4, 5, 6. So 10 to the negative 6th. C and D, we're kind of doing the opposite of what we did in A and B. So this is a huge number. So this is going to have a positive exponent. It's going to be 9.13 times 10 to the positive something, however many places it is to move the decimal point from where it currently is to where we want it to be right there. So 1, 2, 3, 4, 5, 6, 7, 10 to the 7th. Number 6, because this is a negative exponent, this is going to be a tiny, tiny decimal, like 0.000 whatever. So if I take 6.215, 1, 2, 3, 4, there's going to be 3 zeros after the decimal before that 6215. So 0.0006215. The big thing you need to remember is positive exponents are big numbers, bigger than 1. Negative exponents are tiny, tiny decimals, 0.00 whatever. The next one I have requested to go through is number 6. Write the polynomial in standard form. Standard form just means put the largest exponent term first and then decrease from there. So this first one, negative 7x to the 6th, is my largest exponent term. My next largest is x to the fourth, so plus 3x to the fourth, and then plus 5x to the third, and then finally minus 4. The degree is simply the largest exponent. So your degree is going to be that largest exponent, 6. Your leading coefficient is going to be the number in front of the term that has the largest exponent, -7. There's really no trick to this problem. You just have to memorize the degree is the largest exponent. The leading coefficient is the number in front of that term. Next up, number 10. This is a really good one to go through because a lot of people miss this problem. Anytime you see subtraction in between parentheses, you have to distribute that subtraction. So we have here 5c to the fourth minus 3 minus 4c to the third minus 1. You have to subtract both of those. You also have to subtract both of these. So minus 8c to the fourth minus 6c to the third. If we had had subtraction in here, you might run into a case where you have minus a negative, which would change to a positive. Now we just need to combine like terms. Start with your largest exponent of 4. We have 5c to the fourth and negative 8c to the fourth. 5 and negative 8 is negative 3c to the fourth. Then we have c to the third. We have negative 6 and negative 4. That would be 10, negative 10, c to the third. And then we have just the numbers, negative 3 and negative 1. That will be negative 4. Next up is number 12. Number 12 is a very good problem to go through. This is just distribution. And a lot of people were getting confused because of exponents because they see parentheses. This is not really parentheses. There's no exponent here outside the parentheses. The parentheses just indicate that we are multiplying these terms together. So we are going to do 2q squared times 4q to the fourth. 2 times 4 is 8. Q squared times q to the fourth is q to the sixth. You add your exponents when you are multiplying. Then we have 2q squared times 5q to the third. 2 times 5 is 10. Q squared times q to the third is q to the fifth. 2q times 6q. 2 times 6 is 12. Q squared times q is q to the third. 2q squared times negative 4. 2 times negative 4 is negative 8, and you've got that q squared in there. So focus on multiply the numbers and then multiply those letters together, adding the exponents as you go. And in this one, there's no like terms that you then have to add. This would be your answer. Next up is number 18. Expand and simplify. Expand means multiply it out. X plus 4 to the third means x plus 4 times x plus 4 times x plus 4. What you really need to do is focus on 2 of these. There's no way to do all of this in just one step. You have to space this out. Do one step at a time. So first I'm going to double distribute. I'm ignoring that first x plus 4 and I'm just working right here. So x times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. Combine my like terms. Now, we can bring that x plus 4 in the front down, and now we do step 2, double distribute here. X times x squared is x to the third. X times 8x is 8x squared. X times 16 is 16x. Now distribute the 4. 4 times x squared is 4x squared. 4 times 8x is 32x. 4 times 16 is 64. Okay, now we need to combine like terms. X to the third, there's only one x to the third, so we've got x to the third. X squareds, we've got 8x squared and 4x squared. 8 and 4 makes 12. And honestly, once you get to this point, do you see how you already can see where the answer is? You don't have to fully do this problem. Get as much as you need to get your answer and then stop. But if you did want to continue, 16x plus 32x would give you 48x, and then plus 64 at the end. Okay, number 21, long division. For long division, we need x to the third plus 6x squared. Oops, I need to write this so I have room. X to the third plus 6x squared plus 11x plus 12. Notice we started with x to the third and we have no missing terms. We've got 3, 2, regular x, and then a number. We are dividing by x squared plus 2x plus 3. Now, honestly, the 2x plus 3 just come along for the ride. We are really focusing on this x squared in every single step. So, actually, I'm going to highlight that in green. All right, so x squared times what will give me x to the third? That would be another x. Once you figure out what that number is on the top, distribute that to all three of these and write it in the next line. So x times x squared is x to the third. X times 2x is 2x squared. X times 3 is 3x. We then need to subtract. Oh, shoot. Didn't mean to erase all of that. X to the third minus x to the third, that cancels. 6x squared minus 2x squared is 4x squared. 11x minus 3x is 8x. Bring your next term down, and then you're ready to start the next round. X times what is going to give us whatever is directly below that, all the way at the bottom, 4x squared. X squared, we would need the 4. Then distribute that to all three of those terms. 4 times x squared is 4x squared. 4 times 2x is 8x. 4 times 3 is 12. When we subtract this one, all three terms cancel. We have no remainder. And our answer is up here at the top, x plus 4. So our answer is x plus 4. Number 22 with synthetic division, you always need to make sure you check for a missing term. Synthetic division uses the coefficients. And then over here, we write the opposite of whatever we're dividing by. Drop the first number down, multiply. 3 times 2 is 6, add. 3 times 6 is 18, add.